Assalamu alaikum.
Walaikum assalam, sir. How are you, sir?
Alhamdulillah, fine. How are you all?
I'm good, sir. Alhamdulillah.
Okay. So do you have any doubt from last class?
No, sir.
Salman, Khalid?
No doubt, sir.
Okay. So we have just started how to calculate potential energy between different pair, and which I define you between Earth and particular object. Now, related to this concept, we may define two different velocity. First is Scape velocity. Suppose a body is on the surface of Earth. At this point. So due to its interaction with surface of Earth, it may have some potential energy with it. But now suppose if you want to throw this particular object to escape out from the influence of gravity of Earth. So first, is it at this point? Let's say interaction of Earth or gravitational field is up to this point. So if you move this body from this point to this point, so it may escape out from the gravitational influence of Earth. So the amount of energy provided to this particular object, or the velocity with which it may have thrown, so that it will beyond the scope of gravitational influence of Earth, this velocity is called escape velocity. Is it clear?
Yes, sir.
Yes, sir.
So initially, let's say it is at this point A. On escaping out from the influence of Earth, it will reach to this point B. If there is no influence between these two bodies, so at this point, energy of interaction will be zero. So if you have to escape out a particular body from the influence, take its final energy to be zero. So we can define escape velocity as the velocity with which a body must be thrown so that it will escape out from gravitational influence. So we can define initial energy. Energy of body is equals to, it will have some potential energy due to its interaction with Earth and some kinetic energy due to its velocity. So it will half mv square, and gravitational potential energy is gmm by r. So it will be minus of gmm by r. To escape it out from the gravitational influence, final energy of this particular body should be 0. So to escape out from gravitational influence, final energy of this particular object would be 0. Now just equate these two terms and try to find velocity VE. So according to conservation of energy, we can say energy initial equals to energy final. Put the value of each term. So we have half mv square minus of gmm by separation equals to 0. Move this second term to right side. So on solving, you will get 2gm divided by r root under. You may convert this expression in terms of gravity as well. So it will be 2 times gravity into radius. You may convert this particular expression in terms of density as well. So it will be 8 pi rho g times r square by 3 root under. And now if you put all the values related to this part, you will get 11.2 kilometer per second. So this is the final expression of escape velocity of a body on surface of Earth. Is it clear?
Yes, sir.
Yes, sir.
Okay, just write it down, then I'll define you the application of it.
Done, sir.
Salman, you have written?
Yes, sir.
Khalid, done?
Yes, sir.
Okay. Now, according to this expression, you can say there is no any information regarding mass of projected body. So you'll say escape velocity will be independent of mass of body thrown. So it will require same amount of velocity to throw an insect or an elephant. Next, there is no any information regarding direction of projection. So if you throw in any direction at any inclination, you will require only this much amount of velocity, that is 11.2 kilometer per second only. So it will be independent of direction of projection of body. Is it clear?
Yes, sir.
So first, it is independent of mass of body to be thrown. Next, direction of projection. Next application of it is existence of atmosphere. Why there is atmosphere on the surface of Earth, but not on the surface of Moon? And why almost all gases present in atmosphere of Jupiter? So related to this escape velocity, we may define these type of problems. First is, for gases to exist in that atmosphere, we may define a velocity that is RMS velocity of gas. So if VRMS, that is root mean square velocity of gas, is less than escape velocity of that particular surface, then this gas will exist in that atmosphere. But if RMS velocity of gas is greater as compared to escape velocity of that particular surface, so it may escape out from that atmosphere. Is it clear? So for
Yes, sir.
existence of atmosphere, there must be lesser RMS velocity of gas as compared to the escape velocity of that surface. That's why there is no any atmosphere on the surface of a moon, and there is almost all gases exist on the surface of Jupiter. Is it clear?
Yes, sir.
Then gas will exist in that atmosphere. Just write it down to this part.
Done, sir.
Done, sir.
Okay. There is one announcement. In next class, I will take your Viva. Okay.
Okay, sir.
Okay, sir.
For that, you must prepare Kepler's law, gravity. That's it. Okay.
Okay, sir.
Salman,
Which
any
part
doubt?
again? Which parts again, sir?
Kepler's law and gravity only.
Okay.
Okay. Now let me ask you a related question to this part. Suppose from surface of Earth, body is projected along this direction at some angle 60 degree. Find velocity of body to escape it out. If there exists planet having density and radius twice as that of Earth, find escape velocity on that planet. Try to solve. Hiba, what will be your answer for first question? Is it B cos 60 or something else? Salman,
Yes, sir.
what will be your answer for first question?
For 60.
Is it V cos 60? Good.
Yeah.
Hamza,
Yes,
is
sir.
it V cos 60 or something else?
Sir, V cos 60.
MashaAllah, amazing. Khalid,
Sir, V cos minus 60 there.
okay, good. Just read this statement once. What is written here? Escape velocity is independent of mass of body to be thrown and also to the direction of projection. It means escape velocity will remain same for different angle of projection. Is it clear?
Yes, sir.
So now what will be your answer? Salman, is it clear to you?
Yeah, cos 60.
As escape velocity is independent of direction of projection, so it will remain same as 11.2 kilometer per second. It will be independent of angular projection. Okay? Is it clear or do you have doubt?
No, sir, it's clear.
Hamza,
Yes, sir. Clear.
good. Now, next question is, if there is exists a planet whose density and radius is twice of that of Earth, so we have to calculate escape velocity on that particular planet. So you may write escape velocity equals to, in terms of density, as 8 pi rho times gr square by 3. Let's say V1 for Earth, or just VE for Earth. So it will be rho E and it will be RE. Again, for that particular planet, let's say is VP, 8 pi by 3. Density is twice of that of Earth, so it will be 2 times of rho of Earth times gravity, and also radius is twice of that of Earth. So on squaring, it will become 4 times of RE square. Is it clear? Hiba?
Yes, sir.
Now, to relate these two terms, just divide them. So VP divided by VE. All term would get cancelled out, so you will left with root under 8 divided by 1. So we may write 2 root 2. Move this denominator to right side. So velocity of planet or velocity of escape velocity of on that particular planet will be 2 root 2 times escape velocity of surface of Earth. Is it clear? Hamza, any doubt?
No doubt, sir.
Let's say we have density of planet as twice of density of Earth, and radius of planet is twice of that of radius of Earth. So I've just put the value of density to be 2 times of rho and radius to be 2 times of r. So on solving, you will get this relation. Khalid, is it clear?
Yes, sir.
Okay. You all have written to this?
And sir.
Done, sir.
Done, sir.
Okay. Now the next question is, you must know about black hole. Hamza, do you know about black hole?
Yes, sir. Sir, it is like it is a space that leads us to like out of universe or something.
Okay. What is its basic characteristic? Or just imagine why a body looks like black. If it has tendency to absorb light. So in terms of escape velocity, you can say if velocity or escape velocity of a particular body is equal to or greater than speed of light, then it will be capable of even absorbing radiation, or even light can't escape out from that particular surface. Then it is called black hole. Is it clear?
Yes, sir.
Yes, sir.
So for black hole, escape velocity will be greater than equals to c, that is speed of light. Is it clear?
Yes, sir.
Initially, suppose stars which having their own light due to consisting of two different material on it. First is hydrogen and helium, and there is continuous nuclear reaction over it, due to which heat and light will get produced. On complete loss of entire amount of gas present over it, they start shrinking and leads to formation of black hole. Is it clear? So that escape velocity of those heavenly body becomes greater or equal to the speed of light. So those bodies are called black hole. Khalid, any doubt?
No, sir.
Okay. Next is orbital velocity. Suppose a body is revolving around Earth in closed orbit. Let's say a heavenly body at this point is moving with some constant velocity close to the surface. So it must require some amount of velocity so that there will be gravitational force towards center of Earth experienced by this particular body, and there will be some outward force that is called centrifugal force due to its circular path. So if these two forces will cancel out each other, so velocity of body with which it may revolve along this circular path is called orbital velocity. So orbital velocity is the constant velocity with which a body revolves around planet, or let's say Earth, in close orbit. Is it clear?
Yes, sir.
Saman,
Yes, sir, it's clear.
okay. Now suppose a radius of Earth is from this point to this point, and height of this particular body is h. So the total distance from center to that point, let's say small r. So you can say total mv square by r equals to gmm by r square. So m and m will cancel out. So v equals to root under gm by just r. Now, if you put the value of r to be r plus h, so it will become g times m divided by r plus h root under. Now, since h is small as compared to r, so we can neglect h. Therefore, velocity equals to root under g times m divided by r. You may write in terms of gravity, so it will be this. And on putting all the values, you may get 7.89 kilometers per second. Is it clear, Hamza?
Yes, sir.
So this much amount of velocity would be required by a heavenly body to revolve around Earth close to it.
Done, sir.
Done, sir.
Done, sir.
Okay. Next is relation between escape velocity and orbital velocity. So just put the value of these two terms in same unit. So escape velocity is root under times 2gr and orbital velocity is gr root under. So if you divide these two terms, you will get escape velocity is root 2 times greater as compared to orbital velocity. Now, according to this relation, you may be asked a question. By how much percent velocity of moon be increased to escape it out? Is it clear till this part? Khalid, any doubt?
No, sir.
Okay. So for this part, we just assume moon to be a heavenly body revolving around the earth close to it. So it must have some orbital velocity of revolving. So to escape it out from that gravitational pull of earth, some percentage of velocity must be increased to it. So you can say percentage change in velocity equals to final velocity minus initial velocity divided by initial velocity into 100. Final velocity of this moon, to escape it out, should be Scape velocity. So it will be VE. Initially, since it is revolving around the Earth close to it, so it will have orbital velocity divided by orbital velocity into 100. So just put the value of each term. So VE is root 2 times of V naught. So we can write root 2 times V naught minus V naught divided by V naught into 100. Take out V naught as common. Root 2 is 1.414 minus 1 divided by V naught into 100. So this V naught and this V naught cancel out. 1.414 minus 1, it will be 0.414 into 100, it will be 41.4%, or roughly 42%. It means if velocity of moon is increased by 42% of its present value, it may escape out from gravitational pull of Earth. Is it clear? Hiba?
Yes, sir.
Yes, sir.
Any doubt? Khalid?
No, sir, no doubt.
Okay, just write it down.
Done, sir.
Done, sir.
Now let me define you some related term to this velocity. First is if velocity of object is less than orbital velocity, so it may attain some height and then return to Earth. So it will return to Earth after attaining some height. I will define you how to calculate that amount of height related to this part. Next is if velocity of object equals to orbital velocity, then it will start revolving around Earth in circular orbit. Third, if velocity of object is greater than orbital velocity but less than escape velocity, then it will still revolve around Earth but in elliptical orbit. So it will revolve around Earth in elliptical orbit. Next, if velocity of object equals to escape velocity, then it will escape out. Is it clear till this part?
Yes, sir.
Just write it down. You all have written?
Wait, sir.
Yes,
Last.
sir.
Yes, sir. Done.
Salman,
Okay, yes, sir. Done.
okay. Next is how to calculate height and velocity of a body at different instant. In chapter 3rd, motion is straight line or free fall, we learn to use equation of motion. In that part, gravity is constant for its entire motion. But in this, gravity will also change with respect to height or depth. So we can use energy method only to find velocity and height related to gravitational problem. So for height or velocity of body, use energy method. Let me define you a problem related to this. If a body is thrown at v by 2, find maximum height it will attain. Let's say this is surface of Earth. From which a body is thrown upward. So initially it will be at this point. Let's say surface of Earth. A. Thrown upward at some velocity v by 2, so it may attain this height h. So at its highest point, there will be no any vertical component of velocity to move it further upward. So final velocity in upward direction at this point will be 0. Let's say from center of Earth, this is radius of Earth. So energy at point A, this body will have two types of energy. First, due to interaction with the surface of Earth, that will be potential energy, Gmm by R. Next, due to its velocity, it will have kinetic energy, half mv squared. V is v by 2 whole square. At highest point, let's say point P. Since there is no any velocity, so there will be no any kinetic energy, but there is interaction of this particular body to the surface of Earth or with Earth. So energy at point B will be only due to potential energy, Gmm by R plus H, and no any kinetic energy. Is it clear? Salman, is it clear?
Yes, sir, it's clear.
Now, according to conservation of energy, we can equate these two equations. So you'll say energy at point A equals to energy at point B. At point A is minus of Gmm by R plus half m. V is 2 Gm by R on squaring. So it will be 2 Gm by R divided by 2 on squaring will become 4 equals to minus of Gmm by R plus H. So just simplify this equation to find H. Try to solve. Find H in terms of capital R. The rest of the thing will cancel out. Hamza, got any answer?
No, sir, doing it.
Any difficulty?
No, sir, not yet.
Good. Let me solve. Just take out GMM as common. So you're left with minus of 1 by r at this point. This 2 and this 2 will cancel out. So you'll get 1 by 4 times of r equals to minus GMM by r plus h. Is it clear?
Yes, sir.
Now GMM will cancel out in both sides. So you're left with minus of 1 by r plus 1 by 4. Just take LCM as 4r. So it will be minus 4 plus 1 equals to minus of 1 by r plus h. So minus 4 plus 1, it will be minus of 3 by 4r equals to minus of r plus h. This minus and this minus will cancel out. Just cross multiplication. So it will be 3r plus 3h equals to 4r. So 3h will be r. So h will be r by 3. So this body will reach up to r by 3 maximum height. Salman, is it clear?
Yes, sir.
Okay. You all have written?
Done, sir.
Yes, sir.
Okay. Next is satellite, the last part of this chapter. Satellite is basically a body. It may be artificial or maybe natural, which revolves around a planet in a fixed radius or fixed orbit. That is called satellite. A body which revolves around planet and fixed orbit. So we have to define some term related to this satellite. First is velocity of revolving. Let's say Earth and a body is revolving in this circular orbit. So to move a body in circular orbit, there should be some force from center to balance this necessary centrifugal force acting on it. So here we have gravitational force, which must be balancing this centrifugal force. So just equate Fc equals to Fg. Fc is mv square over r and Fg is gmm over r square. This distance from center to this part is small r, which may be r plus h. So m and m will cancel out, r and r will cancel out. So you'll get v equals to root under gm by r plus h. This is the first expression related to that satellite. Similarly, next is time period of revolution. Time period of revolution. According to the formula, T equals to 2 pi r by velocity. So 2 pi r, velocity is root under gm by small r. So you will write root under r cube divided by g times m, or r plus h to the power 3 by gm. Is it clear? Hiba, any doubt?
No, sir.
Done, sir.
Next and most important part of this satellite is to find its energy. So it mainly have two different types of energy. One, due to its interaction with Earth, which is called potential energy. And second, due to its motion, that is kinetic energy. So next is energy of satellite. Potential energy is due to its interaction, it will be gmm by small r. Next, kinetic energy is half mv square. So if you put the value of v from above part, you will get gmm by 2 times of r. Now, if you add these two terms, you'll get total energy as kinetic energy plus potential energy. So on adding these two terms, you will get gmm by 2 times of r with negative sign. Now we have these three terms or these three different energy. So we can relate in this three term as total energy is just opposite in sign of kinetic energy. So it will have negative sign and it will be half of potential energy, that is U by 2. So this is relation between these three different energy. Is it clear?
Yes, sir.
Yes, sir.
There will be a question related to this energy. They will ask you, what is the significance of this negative energy? This negative signifies that satellite is bounded to the gravitational pull of Earth. So this is also called binding energy. Is it clear?
Yes, sir.
So we can say here negative sign in total energy signifies that satellite is bounded to Earth. Hence, it is also called binding energy. Just write it down to this part.
Done, sir.
You all have written?
Yes, sir. Done.
Salman?
Yes, sir, done.
Okay. So this is the entire part of gravitation to this point. So we have just finished this. So let's start new chapter that is from the second term syllabus. Mechanical properties of solids. So to start with it, let me define you some property. Suppose you have spring attached to any fixed support having natural length up to this point. So if you apply a force to change its shape, let's say to compress it till this point. So the force applied on it to change its shape may be called as deforming force. Similarly, you may apply deforming force to elongate it, let's say to this point. So this is deforming force, which is responsible to change the shape of this particular spring. Now this spring has a tendency to retain its original shape on removal of deforming force. So a force will get induced into it. In this part, it will be along this direction. And in this part, it will be along this direction. This developed force is called restoring force. Which will tend to bring this spring back to its original state or original shape. The tendency of spring by which this restoring force get developed into it, which will tend to bring back to its original shape, is called elasticity. Is it clear? That's why we had defined elastic energy or elastic force in chapter 6, work, energy, and power. Hiba, is it clear?
Yes, sir.
So in this part, first we define what do you mean by elasticity. Similarly, just like spring, solid behaves. Consider a solid in which particles are arranged at a vertex of Q. And bond in between them behaves as spring-like, or bond in between them having property of a spring or elasticity. So the structure of it may be like this. Now, if you apply a deforming force on this solid, to change its shape, let's say along this direction. To deform this point to this point. So there is tendency of this body to develop a restoring force along this direction, which will tend to bring this point back to its original position or original shape. This tendency of body is called elasticity. So we can define elasticity as the tendency of body due to which they can regain their original shape on removal of deforming force is called elasticity. Salman, any doubt?
No, sir, no doubt.
Similarly, we may define opposite of this behavior, that is called plasticity. It means the tendency or the inability of a body so that they can't regain its original shape on removal of deforming force, that is called plasticity. The inability of body so that regain its original shape on removal of deforming force. In general, there is no any object which is perfectly elastic or perfectly plastic, but some object may show maximum elasticity or maximum plasticity. So most elastic substances, quartz, and similarly, most plastic is wax. In general, property of body will lie in between elasticity and plasticity. So you can say behavior of body lies in between elastic and plastic. Hamza, any doubt?
The wax can regain its shape, right?
No, it can't regain. That's why it having maximum plastic behavior.
Okay, sir.
Done, sir.
कहते हैं हमको सलाम नहीं। You all have written?
Yes, sir.
Now, related to this deforming force, we may define some term. First is stress. Suppose you have a rigid body attached to any vertical support. So if you apply any deforming force on it, let's say along this direction, a force which may cause some deformation in it. So it is called deforming force. So this rod will behave like spring. So on applying this deforming force, there will be some deformation along its length. So it may get stretched to this point. So actual length of this rod is from this point to this point. Elongation is from this point to this point. Area of cross section is A. So stress is basically the amount of deforming force applied over this particular body per unit area of cross section is called stress. So stress is the amount of deforming force applied on a body per unit area of cross section. So stress equals to deforming force divided by area of cross section. Hiba, is it clear?
Yes, sir.
Now, since in this part, stress is related to force and area of cross section, so its SI unit will be Newton per meter squared. Now, next is corresponding to this deformation or this application of stress, there will be some amount of deformation in it, let's say delta L or along its length. So if you have to measure amount of deformation produced, we may define another physical quantity, that is strain. So strain simply defines you the amount of deformation produced in this particular object per unit original shape. So strain is basically ratio. The ratio of deformed shape to the original shape of body. So strain equals to deformed shape divided by original shape. Since unit of deformed shape and original shape will be same, so they will cancel out. So strain will be unitless quantity. Salman, any doubt till this part?
No, sir, no doubt.
Good. Just write it down.
Done, sir.
Done, sir.
Salman, you have written?
Yes, sir. Done.
Now, there is a relation between this stress and amount of strain produced, which is defined by Hooke's law. But there is some limiting condition for this. First is temperature should be constant. Why it should be? If we increase or decrease temperature, it will affect in bonding of that particular particle. Suppose if you raise the temperature of body, so increasing temperature will responsible for a weakening of bond in between the particle. So separation between particle increases, then it will have lesser ability to regain back to its original state than its original part. Or you'll say it will lose some of its ability to elastic or elasticity behavior. That's why temperature should be constant. Next, nature of material should be same. And it should be within elastic limit. I will define you later what do you mean by elastic limit. So Hooke's law state, at constant temperature and within elastic limit, the more you apply stress to a particular body, the more deformation will produce into it, or the more amount of strain will develop into it. So stress and strain will be directly proportional to each other. So according to Hooke's law, at constant temperature, and within elastic limit, the strain developed or produced in a body is directly proportional to the stress applied. It means stress applied is proportional to strain produced or developed. If we replace this proportionality sign by any constant term, so it will be stress equals to some E times strain, where E is called modulus of elasticity. Is it clear till this part? Iba?
Yes, sir.
Salman, any doubt?
No, sir. No doubt.
Okay. Now, since stress and strain is directly proportional to each other, so we can draw its curve. So stress is directly proportional to strain. So graph will be straight line. This is amount of stress applied, and this is corresponding strain developed. Since this line will have some inclination with x-axis, let's say theta. So if you resolve this particular equation, you will get E equals to stress divided by strain. In terms of graph, this is perpendicular by base, which will define slope of that particular curve. So you can say slope of stress strain curve will give you modulus of velocity E. It means E equals to just tan theta. Salman, any doubt?
No, sir. No doubt.
Okay, just write it down to this part. You all have written?
Yes,
Yes,
sir.
done.
Now let me define you the characteristic of modulus of elasticity and property of modulus of elasticity. This modulus of elasticity will define the elastic behavior of substance. It defines the elastic behavior of body. Next, it depends upon nature of material and temperature. It depends upon nature of material and temperature. So this modulus of elasticity will inversely proportional with temperature. If you increase the temperature, bond get weakened, separation between particle increases, hence elasticity of body will decrease. So elasticity or modulus of elasticity will be inversely proportional with temperature. Next is, it will be independent of dimension of body, whether you will increase or deform dimension of a particular modulus of elasticity will remain. So it is independent that is length, radius, area, and so on. Next, since and strain is a unitless quantity, so the unit of modulus of elasticity will be equivalent of stress. So its SI unit is Newton per meter square. Hamza, any doubt?
No doubt, sir.
Okay, just write it down till this part. You all have written till this?
Yes, sir.
Any doubt to any one of you till this part? Okay. Now let me ask you a question. If you have a graph or two different material related to stress, strain. First is this having inclination 30 degree, is having inclination 60 degree. Find the ratio of modulus of elasticity for A and B. Try to solve. Just use the above concept what we had derived. If you have any graph related to stress and strain, so just use E equals to tan theta. We have inclination for A and B. Just put the values and divide them. Hamza, you got any answer?
So it will be 1.
Okay, 1. Kiba? Suppose for A, what is theta? (60°). So tan of 60° is nothing but √3. Second, for B, theta is 30°. So tan 30 is 1 by √3. So just divide these two terms. This √3 is in denominator of denominator, so it will move to numerator. So on get multiplied with √3, it will become 3. So E of A divided by E of B will be 3 divided by 1. That is 3:1. Is it clear?
Yes, sir.
Yes, sir.
Salman, any doubt?
No, sir. No, sir, no doubt.
Okay. You all have written?
Yes, sir.
Yes, sir.
Okay, so on the basis of these three terms, stress, strain, and Hooke's law or modulus of elasticity, we may define its type. So first is longitudinal. Suppose there is a wire attached to vertical support. Deforming force may be applied in these two different bodies in two different directions. In first part, let's say deforming force is applied along this direction to elongate it, and the second part along this direction to compress it. So this first part is also called tensile, and the second part is also called compressile. Now, due to this deforming force, there will be some deformation along its length. So this is delta L. Original length of rod is L. Similarly, in the second part, deformation will be till this point. And actual length of rod is N. So first, tensile stress. The amount of deforming force per unit area to elongate it is called tensile stress. Amount of deforming force per unit area to elongate it is called tensile stress. Similarly, compressile stress is amount of deforming force per unit area to compress it is called compressile stress. And both these two terms is along length itself. So combinedly, it is called longitudinal stress. So first we define longitudinal stress as deforming force over area of cross-section. Iba, is it clear?
Yes, sir.
Now, due to this deformation or due to this longitudinal stress, amount of strain developed or produced is called longitudinal strain. That will be delta L divided by L. Now, if you divide these two terms, which will define modulus of elasticity, and in this part along its length, it is called Young's modulus. So Young's modulus equals to longitudinal stress divided by longitudinal strain. Young's modulus is denoted by capital Y. Longitudinal stress is force by area of cross section. Longitudinal strain is delta L divided by L. So on simplifying, you will get F into L divided by A times delta L. And since this modulus of elasticity is along length, so it is also called elasticity in length. And next is, since length is defined only for solids, so you'll be asked whether Young's modulus will be defined for liquid or gas. So you'll say no, as we can't define specific length for fluid. Is it clear?
Yes, sir.
Okay, just write it down to this part. Khalid, any doubt?
No, sir.
Okay.
Done, sir.
Salman, you have written?
Yes, sir. Done.
Iba, done?
Yes, sir.
Okay. So this chapter is basically very easy. We have to define some term related to some deformation. Let's stop here for today. In next class, I will define you the rest part of this chapter. Then we'll start fluid. Okay? Hamza, any doubt till this part?
No, sir.
Okay, so most important, just revise gravity, acceleration to gravity, and Kepler's law for your Viva. Okay.